Our next speakers are New Zealand speakers again. Happy that I say that. From Ngāti Wharetoa Geothermal Assets in Kawerau, and Spence McClintock will be the first speaker. Spence.
Ti hei mauri ora, ena mana, ena waka, ena rea, tēnā koutou, tēnā koutou, tēnā koutou katoa. Ko Spence McClintock taku ingoa, ko tū wharetoa mai kawarau ki te tai, taku iwi whāngai. So, welcome for wherever you've come and however you got here. And my name's Spence McClintock and I work for the Tū Wharetoa Mai Kawerau Ki Te Tai group. So we're a Kawerau-based iwi organisation, and geothermal is just part of what we do, but just to translate the name, it's Tū Wharetoa from the town, from Kawerau to the sea, so that's where Mai Kawerau Ki Te Tai comes. So today we're just going to cover our geothermal business for your benefit, and really direct heat and electricity generation. We also do a lot of other things, farming interests, industrial property interests, and cultural interests for Tū Wharetoa and Kawerau. So we're going to my colleague Jaime Quino is going to cover some details on the Kawerau system, along with Wairakei, one of the two long historic development systems for industrial process heat and electricity in New Zealand. And then we'll get into some detail about our geothermal assets business, which was mainly originally a heat supply business to all of the industrial businesses in Kawerau. So we'll tell you a little bit about that. But we're in a unique position being an iwi-based organisation where we have two roles in relation to geothermal. Our first and most important role is as an acknowledged kaitiaki of the Kawerau resource. So that word that you've heard already today, custodian or guardian. And that's not only as identified by the tribe themselves, but also acknowledged by the Crown. As part of a statutory acknowledgement in the Crown processes when settling historic grievances with the Tū Wharetoa iwi. The Crown acknowledged Tū Wharetoa's role in being custodians of the Kawerau resource. So that's our first and most important role. Secondly, we are also a geothermal developer ourselves. So that's at times a challenging position to be in. So I'll hand over to Jaime, and he is a geothermal scientist. He's our senior geothermal reservoir engineer, and he can tell you a bit about the history of the journey of the Kawerau development, and then I'll tell you a bit about geothermal assets.
Thank you, Spence. Konnichiwa to our visitors, and tēnā koutou katoa. Good afternoon, everyone. So I'm going to provide an introduction to the Kawerau geothermal system and an overview of the industrial development of the Kawerau geothermal field as part of this presentation. So the Kawerau is located in the northeastern end of the topovolcanic zone in the North Island of New Zealand. So it's shown as the orange circle in the map. It's also to the northeast of Rotorua, where we are now. The TVZ hosts majority of the New Zealand geothermal systems. The geothermal field covers an area of around 22 square kilometers with a natural surface heat flow of around 100 to 150 megawatts thermal. So looking closer to the Kawerau geothermal system, in here is a cross-section of the geothermal field that shows the Putuaki volcano at the background, as you can see there. And if you draw a cross-section line from top to bottom of this left-hand figure, you would see the southeast to northeast projection to the right-hand side. So Kawerau is a liquid-dominated geothermal system believed to be driven by the heat from the Putuaki volcano as its likely heat source. Deep thermal fluid upflows through the spaces, faults, and fractures of the basement rock, or the Greywaki, from the south near the volcano, and then it flows laterally through overlying permeable volcanic and sedimentary layers on this side here. So the hottest temperatures measured is around 310 degrees, and the fluid generally flows from the south, mixing with groundwater as it flows up through the surface features, and northwards as it mixes with cold meteoric recharge as it flows northwards into the Tarawera and Rangitaiki floodplains. Natural recharge to the system comes in as cold meteoric recharge through natural convection and through permeable pathways in the rocks. So prior to the geothermal development, industrial geothermal development in the area, the Ngati Wharetua people has been extensively using this resource, originally known as the Unepu Thermal Area or the Unepu Springs, for healing and recuperation, cultivation of plants, especially kumara, heating, cooking similar to hangi, warmth, a breeding ground for eels and morihana, bathing, and sulfur for medicine. There were records that the area was also a site of a sulfur mine back in the 1880s. And up to the 1950s, when the industrial development of the Kawerau geothermal field began, the Ngati Wharetua people were still extensively using the geothermal resource. So these are photos of the area in the 1950s. The Unepu Springs area was developed to supply steam to the new Tasman pulp and paper mill, now known as Norskiskog Tasman. And you could see it in the foreground here as that construction was happening with Mount Putuaki at the background. The site was chosen for a pulp and paper mill due to its forestry, geothermal energy in the area, and water resources in the Tarawera River, and what was then a planned link to Tauranga, which is one of the biggest ports in New Zealand. By 1953, the township of Kawerau was established, which housed most of the people working in the mill and in the geothermal development. So these are photos of the development drilling that happened in the succeeding years. And by 1957, around 17 wells were drilled to supply fluid to the Tasman pulp and paper mill. And this geothermal steam supply business was fully operational by 1961. So the left photo in there is a flow test using three nozzles. And these are vertical discharge tests happening to blow out the debris from drilling. So this is an overview of the milestones in the development of the Kawerau geothermal field. This was adapted from a timeline at the Bay of Plenty Regional Council website. And we've adapted it to show the milestones at the top, development milestones, and then the response to the development at the bottom. So while the thermal features in the area were observed to be naturally declining as early as the 1900s, the geothermal system response to the initial development in the 1950s shows an initial acceleration of thermal features decline from around 1950s to the 1980s here in this period. But as you can see in terms of the effects from the reservoir perspective, the reservoir pressure decline was less than a bar. So that's not a big drawdown when you think of it from a development perspective. However, note that the shallow pressure has dropped by about 3 meters of water level. That's equivalent to about 0.3 bars, which is attributed to the geothermal system. The total change in the water level is believed to be around 6 meters, a combined effect of the downcutting of the Tarawera River and the geothermal operations. But note that the shallow pressure decline in here shows how sensitive how sensitive the surface thermal features are to the water level changes. In response to the initial inflow of colder water into the shallow wells during that time, the wells were then drilled deeper. So initially, the wells were drilled at around 250 meters, but then it's now a lot deeper at around 1 kilometer into the reservoir. And recent developments are drilling up to like more than 2.5 kilometers into the reservoir. So as you can see as well, recently in here, infield reinjection was initiated around 1991, and that's to reduce the brine discharge to the Tarawera River. So the entire period of development from the 1950s up to here, the separated brine was discharged to the river. However, the reservoir pressure drawdown was minimal at less than a bar, which means the recharge into the system was quite strong. By around 2000 to 2005, there were investigations for further electricity generation. By 2005, NTGA acquired the ownership of the Crown geothermal supply business and became active participants in the development of the Kawerau geothermal field. Most recently, in 2008, there is an increase in geothermal take because of the entry of multi-tappers into the system. But these take were from deeper regions of the reservoir into the Grey Wacky basement, resulting in an initial reservoir pressure transient decline of less than 6 bars, and it has now stabilized at around 0.25 bar per year. And it also involves reinjection of the separated brine into the deeper parts of the reservoir as well. These are the observations so far of the recent development, and that overall drawdown and stabilization has shown that it's a sustainable process. Thermal features, because they were naturally declining to start with, are still expected to decline, but not at the accelerated rate seen before. Some of the affected thermal features are supplemented with hot brine, like the West Lagoon, and extensive monitoring is regularly carried out, like ground subsidence monitoring, water level monitoring, among others. So looking at Ngāti Te Wharetoa Geothermal Assets Limited, our supply of geothermal energy to the Kawerau industries is the world's largest geothermal direct heat supply. And as you can see from that initial development to the current Kawerau industrial complex, the Kawerau geothermal field has been supplying geothermal heat for 60 years, and NTGA has consents to utilize up to 89,000 tons of geothermal fluid per day, ready to meet future customer demands for clean, renewable energy. At this point, I will hand over the presentation to Spence to discuss our recent journey.
Thanks, Jaime. So just some pictures here. Bottom left corner is our clean steam plant. So in 2013, we began supplying steam to the local Asalio tissue plant for the manufacture of food-grade tissue. So a heat exchanger, considerable investment, and that operation displaced gas for gas boilers in the Asalio tissue plant. 2015, we began working out of our new office and began operating the assets ourselves. So we had a previous management arrangement, and then we took over operating and maintaining our own assets. 2015, partway through the year, we drilled a new well. In 2016, we purchased a 21 megawatt geothermal power plant at Kawerau. Jaime's already described the geothermal complex, just a different perspective. So on the site, there is a pulp mill, newsprint mill, a tissue plant, and sawmill, and all of those businesses, one way or another, utilise geothermal steam. Just want to touch down here. This is an area just, so this You might not be able to make it out, but there's a little serpentine channel here, so there's still some river discharge out of our industrial processes on the east bank of the river, and on the west bank of the river we have some separator equipment. There's a small power plant, and the outfall of that small power plant is discharged into a lagoon area here, and there are some baths just constructed off that lagoon, which local hapu use, the Savage Baths. That's really an adaptation and a replacement for what was some geothermal features in that area up until the shallow drilling reduced the aquifer and reduced those shallow features. So the utilisation of those baths and the enjoyment from those baths has been altered, and but it is still in existence and utilises fluid from operations. Just want to touch briefly on some direct heat challenges. Running a direct heat supply business is not straightforward. Customers all want different pressures and temperatures, so trying to run a network of assets can be challenging. Some customers can cope with raw geothermal and the properties of that. Others require clean steam, but most actually require quite high temperature. So we regularly hear descriptions of cascade use, which sees electricity at the top of the tree and direct heat users at the bottom. In our experience, often the reverse is true. Some of the clean steam customers have very high pressure and temperature to the point where we have another go at using that fluid again for electricity generation. So yeah, it's and direct heat customers can often have quite low utilisation. They can be, some of them can be batch processes, and they're not necessarily running all the time. So trying to recover your investment, whereas typically your electricity, as long as everything's operating well, is base load and up in the sort of mid 90% utilisation. And many of our direct heat customers are down closer to 70%. The other point about direct heat is typically customers are small relative to electricity generation scale. So a world-class sawmill, for example, might use 30 tonnes per hour of geothermal heat. If you convert that into electricity, you might be talking 5 megawatts, so a fairly modest, small, whereas that would be a global world-class sawmill cutting 700,000 or 800,000 tonnes of logs. So it takes quite a lot of work to get a large-scale geothermal heat business. This is just some of our customers. Tissue plant, Norske Skog, two different sawmills. Some new possibilities we're working towards. There's possibility of a particle board manufacturer being established in Kawerau. Various options looking at sawdust possibility, possible milk powder plant, and we're working with OG to whether there are some further possibilities with them to do more with geothermal in their business. We're also looking at general sort of horticulture assistance type processes. So with that, any questions? No, not allowed questions, not enough time. Nope, that's us. Kia ora koutou.